Hello, everybody. By popular request, I've decided to post a Unit 4 review. So I'm going to go over a problem solving question from each lesson to give you a little bit of practice before you have your test. All right, so let's go and jump into the first one here. The volume V of gas varies inversely with pressure P. If the volume of gas is 6 centimeters cubed with a pressure of 25 kilograms per centimeter squared, what is the volume of gas at pressure of 15 grams per centimeter squared? Now, the first thing we need to know, the first key is that it tells us that our gas varies inversely with the pressure, which means that there's a couple ways we can write this. We can say V times P is going to equal K, right? Where V is our gas, P is our pressure, and K is the scale factor of the problem. You can kind of look at it as like the slope, right? We can also look at this as, and the way that'll help us for this problem more will be, well, if we know that it's 6 centimeters at a pressure of 25 kilograms per centimeter squared, and then on the other one we already know the pressure, then we're actually going to be kind of solving for the volume. So we want to put the volume on one side, so we can say the volume equals, if we divide both sides by P, we'll get K over P. And this here is the one that's going to help us a little bit more. All right, so let's go and use the formula here first. Okay, so we know that the volume of gas is 6 centimeters, so we have 6 centimeters with a pressure of 25 kilograms per second. And that's going to equal like our slope or scale factor for this problem. So we do 6 times 25, and we're going to get that K equals 150. All right, and that's going to be important because now we can use that as like a rule, so we can actually plug in the information we have for the other scenario. So what is the volume of gas at a pressure of 15 kilograms per centimeter squared? Well, let's go ahead and use this other formula. The volume is the thing we don't know, but we're going to set that equal to K, which we just decided was 150, over our pressure, which is 15 kilograms per centimeter squared, which is, of course, going to give us our volume, which is 10 centimeters cubed. And now, like I always say, you can go back and you can check the math completely, you can redo that, but we should always ask ourselves, does this make sense? So if at 6 centimeters cubed, it was at 25, and we vary inversely, then as the pressure goes down, the amount of gas should increase, right? Because it's inverse, it should work in the opposite way. So it did, right? We went from 6 to 10, which means that it did increase. So the answer does make sense. We can go ahead and put a circle around it and feel pretty good about that. All right, easy peasy. All right, number 2. The attendance at an amusement park after day X is given by the function f of x equals 3000x over x squared minus 1. On approximately what day will attendance be 1,125 people? Okay, so problems like this are usually much simpler if you establish what the variable is. So it's saying the attendance at the amusement park after day X. So our X coordinates is going to be the day, right? Or how many days. And then our Y, our f of x, this entire function is the attendance, right? So Y equals the attendance. Well, the reason why this is important is because if we had some kind of a visual guide that told us what X was when Y equaled 1,125, then we'd have the answer right away, right? Fortunately, we do have one of those guides. We call it Desmos. So all we're going to do is we're going to go look at Desmos and we're going to figure out, well, where does Y equal 1,125? So I've already taken the liberty of graphing it here. And now we're going to say, okay, where Y equals 1,125, let's go up here, 1,100, we're getting there, 1,125, looks like the answer is, almost. It's going to be 3, right? You can see how close it's getting. I just can't get it there. There we go. 1125, 3. So in other words, what this is saying is that on day 3, we will have an attendance of 1,125. So that's the easy way to do it, right? Let's just go ahead and write that down. Well, we have 3 days. We used a graph to find the answer. So real quick, the question would be, just we're not going to go through the whole problem, but how would you do this if you didn't have Desmos? Well, it's actually kind of the same idea, right? We need to know at f of x what x equals. So essentially what we would do is, because we know the y has to be 1125, we would plug that in. So we know that at 100, or in order to have 1125 people, this is going to be equal to this function. So 3000x over x squared minus 1. And now essentially what we would do is we would solve for x, right? So we would break this down. We would get x plus 1, x minus 1. We'd eliminate common factors. We'd pull this over, set it equal to 0, do all that stuff, solve for x. And you'd end up getting two answers, right? Because we have an x squared. So you'd end up getting two answers. Only one of them would be positive, which in this case would be 3, right? So if you want to go through and you want to do all that math, just to kind of show yourself how to do it, you absolutely can. And if you want help with that, I guess come in before school tomorrow, and I'll help you with it. All right, so that's that one, 3 days. All right. So, next question here. The volume of a rectangular prism with a square base can be represented by the function 25x cubed plus 200x squared. The height can be represented by x plus 8. What is the side length of the base of the prism? Well, let's think about this. If we have a rectangular prism, right? So basically what they're saying is they're saying the base is a square. I'm going to do my best here. Okay, so that's kind of squarish. And then it has a height, right? This is the base. We don't know what these things are. That's what we're trying to find. But we know that this is going to have a height, right? Like this other dimension, our third dimension here. We know that this third dimension is x plus 8. Right? This dimension here, it doesn't really matter which one we're talking about. Here, let's do this. Let's say that this is our base, right? We can do like this background thing. Let's say that this is our base here, and that our height is this value, just to make it a little bit easier. Okay, so x plus 8 is the height. We need to know the base. Now, if the base is a square, we know that both the height and both of these parts, right? We know both of them are the same. So first of all, if we take our original function that they give us here, the 25x cubed plus 200x squared, if we take that and divide it by this x plus 8, they're going to give us what would be like the surface area of the base, right? So we can find the area of the base by going down one level. In other words, dividing our volume by the height. So let's do that first. And we have x plus 8, which is a binomial, so we can use synthetic division. So if it's x plus 8, that means we know that our 0 is actually negative 8, right? And so we can put that one in the corner, and now we can do our thing. So we have 25 plus 200x, so 25, 200, 200x squared. Our x would just be 0, and then our constant would also just be 0. So that would be kind of it for this. So let's go and do it. So we bring down our 25. 25 times negative 8 is negative 200. Now we're going to get to 0, 0, and 0. All right, so we do have a remainder of 0, so we know that it goes in evenly, which means, I mean, we already knew it was a factor, but now kind of confirms that it's a factor. So this tells us that essentially this polynomial, or this polynomial expression here, is going to be x plus 8 times the quantity. Well, here we have a 25, right? And so this would be our x squared value. So this is all it is. So it's just 8x squared times 25x squared. And now the question is, how does this 25x squared help us? Well, we know that this 25x squared has to be the thing that's multiplied by the height. So in other words, this is our like length times width, right? Length times width, if this is our height, that's how we get, this is how we would get the volume, right? So if this is our length times our width, in order to find one of the sides, we basically have to take the square root of this, right? Because on a square, both sides, it's one side times itself essentially, because they're the same number, right? So what we're going to do is we're going to take 25x squared, and we're going to take the square root of that to find just the side length of one of them, right? And I mean, we can just, if you want to look at this as the square root of 25 times the square root of x squared, you can do that, which will give us 5x and this is our side. So this is 5x, and this is 5x. And if you don't believe me, well, what can we do to check our work? This is one that's really easy, just to plug the stuff back in and see if it works, right? So basically what we said is 5x times 5x times x plus 8 has to equal our entire volume, which we said should be 25x cubed plus 200x squared. So let's just go ahead and do that. Let's just double check. So we have 5x times 5x times x plus 8. So let's do it. 5x times 5x, that's 5 times 5, which is 25. X times x, which is x squared. And we're multiplying that by x plus 8. 25x squared times x is 25x to the third. And then 25x squared times 8 is plus 200x squared. And wouldn't you know it, 25x cubed plus 200x squared is exactly what our original expression was. So we were able to check our work. We know that the side lengths have to both be 5x, and then the height of our little rectangular prism is x plus 8. All right, cool. Lesson 4. Mia paddles a kayak 6 miles downstream at a rate of 4 miles an hour faster than the river's current. She then travels 6 miles back upstream at a rate of 2 miles per hour faster than the current. Write and simplify an expression for the time it takes for her to make the round trip in terms of current c. Okay, so first of all, they already kind of told us this, but let's establish that variable quickly. So we're going to let c equal the rate of the current. And of course, if it's a rate of a current, it's going to be in miles per hour. Okay. Now we have to think about what this is asking us. So it's asking us to write an expression essentially expressing the time that it takes for her to make this trip, right? So the time it's going to take is going to be, it's going to be the time that she takes traveling upstream combined, so plus the time that it takes to go downstream, right? That's basically the idea. She's going to go downstream first, and then she's going to work her way back up. What's the time it takes for her to do both of those? So if we can find the time upstream, or we can find an expression for the time upstream, and then find an expression for the time downstream, we can add those together, and that will give us our expression. Now, how can we find time? Well, we're talking about a rate of speed, right? We know that speed equals distance divided by time. And we need to rearrange this formula so that we're actually solving for time, right? Because we need the time of both of these things. So if you rearrange this formula, you multiply both sides by time and then divide both times by speed. And essentially what you'll get is you'll get you'll get time equals, if you want to rearrange this formula, you can. I promise you this is the answer. So we'll get time equals distance over speed, okay? And this is what we're going to use for both of these things. We're going to use this as our little formula for the time downstream, and we're going to use this as our formula for the time upstream. So let's just go ahead and plug the stuff in that we know. Like, this is what we have in the problem, right? So Mia paddles a kayak 6 miles downstream. So the function of our time expression here is going to be distance over speed. Well, we're going a distance of 6 miles downstream. So let's just go and do downstream first, right? Downstream. Okay. So we have 6 miles over our speed, which it says is a rate of 4 miles an hour faster than the river's current. Well, if you're going downstream, right, if she's paddling at 4 miles an hour, that's in addition to the rate of the current, right? Because the current would be pulling her downstream with her. So the rate of the current, which is c, is going to be added to her rate, which we said is 4. So the entire denominator, our entire speed here, is going to be the current plus 4 miles an hour. The current's miles an hour plus 4 miles an hour. All right, now upstream, when we're going upstream, right, and we're adding these things together, when we're going upstream, we're traveling 6 miles back up, which makes sense because we're going the same distance, right? And then it says 2 miles an hour faster than the current. So here it's going to be our current, but in this case, our current is fighting against us, right? So we're actually going we're actually going to be going our current minus 2, right? And the reason why is because our current is fighting against the 2 mile an hour that we're going. So that's going to be the total speed, is going to be whatever the current of the river is minus the 2 that we're going. All right. So now let's go ahead and add our stuff. So we have c plus 4, c minus 2. So let's go ahead and find a LCD, right? Just like we did before. So the LCD in this case, we have a c plus 4, c minus 2. There's not really much we can do for this other than just multiply them together. So our LCD is simply going to be c plus 4 times c minus 2. And now we're going to take our two expressions here, and we are going to find the pieces they don't have. In other words, this first part here, our first expression here is c plus 4. In order to get the LCD, we're going to need c plus 4 over c minus 2, right? And I'm going to write this as one giant expression. So this is going to be c plus 4, c minus 2. And what we're going to do is we're going to add these two pieces together, right? And then we're going to get the same denominator. So if this side was 6 initially, the numerator is initially 6. We had the c plus 4, so we need the c minus 2. So on this side, it's going to be 6 times the quantity c minus 2. And then on this side, we're going to have 6 times the quantity. Well, this time we have the c minus 2, right? So we need the c plus 4. So c times the quantity, or 6 times the quantity c plus 4. Now we can distribute this out a little bit just to see if we can do anything with it. Remember that when you're adding expressions, it's kind of a mix of factoring and then simplifying and then factoring back and forth to see what you can get. So let's go ahead and do that. So we're going to get 6c minus 12, right? And then plus 6c plus 24, right? And this is going to simplify into 12c plus 12. Right? So now we can take a 12 out of that. So we can take a 12 out and we're going to get c plus 1. Now this is our numerator. Of course, all of this is over our denominator. And then we can see if there's anything that can cancel. Right? c plus 4 times c minus 2. And of course, there isn't anything that can cancel here. There's no c plus 1 on the bottom. And the 12, there's no other numbers that can cancel with. So this would be our simplified expression. I know it doesn't look completely simplified. And if you want to, you could foil the bottom, right? And you could refoil the top, and you can make it look prettier. But ultimately, this is the simplest form that it gets into. All right, excellent. Okay, last one. Here we go. Diego and Hector can paint a doghouse in 5 hours when working together. Diego works twice as fast as Hector. How long would it take Diego to paint the doghouse alone? All right, well, this is what is known as a work rate problem, right? So essentially, our work rate, or our rate of work, or whatever you want to call it, is going to equal the total number of jobs. In other words, the amount of work, right, over the amount of time it takes. So total number of jobs over time, cool. And if we're trying to figure out how much each of them do, if they're working together, it takes them 5 hours. So the total is going to be one job per 5 hours. All right. Now it's going to be a combination of both of their rates. So it's going to be Diego's rate plus Hector's rate, right? Well, what's Diego's rate? Diego can work twice as fast as Hector, right? So we don't know how much time it's going to take them each individually, but we know that if we let's do Hector first, because that might be a little bit easier. Right? If we do Hector first, we know that Hector can do one job in X minutes. Right? Or X hours. We don't know exactly how many hours it takes, but we know he can do one job in that amount of time. We also know that Diego can do twice as many jobs. Right? You could say he works twice as fast, right? But that means two things. It means either A, in the same amount of time he can do 2 jobs, or it means B, he can do one job in half the time, right? It's both the same idea. So either way, we can say that this is plus 2 over X, because in that same amount of time, he can get 2 jobs done, right? And of course, this one is Diego. And now we have an equation we can solve. We have 1/5 equals 1 over x plus 2 over x. So let's just do this. So let's find the LCD first. Our LCD in this case is just going to be 5x because we just kind of multiply everything together. So let's turn each of these fractions into something with the same denominator. So here we have a 5 in the denominator. We need to multiply it by x. So we're going to multiply the top and bottom by x, and we're going to get x over 5x. And that's going to equal, well, here we have an x in the denominator, and we need 5x in the denominator. So we're going to multiply the top and bottom by 5. So 5 over 5x. And on this last one, we have an x in the denominator, and we need it to be 5x. So we're going to multiply the top and bottom by 5. So in this case, we have 2 times 5, which is 10, over 5x. And now because all of the denominators are the same, we can basically ignore them and just use the expression in the numerators to solve for x. So we know that x equals 5 plus 10. In other words, x equals 15. Now, what was the question it was asking us? How long would it take Diego to paint the doghouse alone? Well, it takes Hector X hours to do one job, right? Which is 15. So if it takes Hector 15 hours, how long would it take Diego to paint the doghouse? Well, it would take him half of that. So 15 divided by 2, which means that Diego is 7.5 hours. All right. Awesome. That's it. So, if you have any questions about that, please come see me before the test tomorrow. We'll go over this a little bit in class as well. So if you have any questions, prepare them for that day so that way we can go over it. But yeah, if you have any, like I said, if you have any questions about this, just please prepare them for class. And this will be it for the review. Good luck during the test.